So, what I want to talk about in this lesson is this idea of energy levels in atoms. And it really relates to the electron. So, it's a subatomic particle, as we know, and it's a negatively charged subatomic particle. So, what we're talking about then are where do these electrons hang out in relation to the nucleus of the atom? So, if we look at the official definition of an energy level, so an energy level is a region or a definite energy within the atom that electrons can occupy. Okay, so regions. And what they do is they distinguish these regions, they actually call them levels. So n equals to 1. So working from the middle, so in here we have the nucleus, and then working out from the nucleus, then you have these regions. And the first region that you have, which is closest to the nucleus, is level 1 or region, this region here, so n is equal to 1. And that's that first band that we see there around the nucleus. Then moving out from that, then we have n is equal to 2, n is equal to 3, n is equal to 4, and n is equal to 5. So each of these regions then, they have different capacities for electrons, as in the number of electrons that can occupy these particular levels. And they also have different energy values as well. So if we think about the n is equal to 1, or this first region that's closest to the nucleus, it can contain up to, so it can hold 2 electrons. Okay, so it can hold up to 2 electrons. So that's the max that we can get in there. When we start to move out then, if we look at the next level, so this is n is equal to 2, so this n is equal to 2 level, it can hold up to 8 electrons. So you have 2 electrons in the first shell, which is n is equal to 2, and then the second shell you'll have, it can hold up, it has a capacity to store up to 8 electrons. Then if we move out another level, so out to the third energy level, or energy region, or level if you like, and so that's the n is equal to 3, and it can hold up to 18 electrons. So it has a capacity. So remember, we've seen this word here, region space where electrons can occupy. So it has a capacity then for 18 electrons. And then so that's the n is equal to 3. If we go out then further then out to this n is equal to 4. So again, we're moving out, as you can see here. So in the region, or the energy level n is equal to 4, it can hold up to 32 electrons. 32 electrons. So we can see here the energy levels as we move out from the nucleus, the capacity for the energy levels to hold more and more electrons increases. And as you can see, the sphere, or the radius, also increases as well. So there's actually more space for electrons to hang out further and further away from the nucleus. So we're just going to look at the first 4 energy levels, just for chemistry for these purposes. So these are the energy levels. So each level is n, and it's n is equal to 1. That means the first energy level, and so on, right the way down to 4. And then these are the capacities for storing electrons. This is the storage space, or the amount of space that's available for electrons at each of these energy levels. So what I'm going to look at then here, so this here then is a table, and what it actually shows is the arrangement of electrons for the first the first 19 elements on the periodic table. So just to kind of give you an idea of the pattern and the way these are arranged, and I might just draw a few of these just so you kind of get an idea. So if we take the first one, so hydrogen, So hydrogen. Hydrogen is the first element on the periodic table. So it has one proton. So if we draw it, so imagine this is the nucleus. So this is our nucleus. And what we're going to have then outside of this, we're going to have one region of, so I'm going to do it like this. So imagine we have our, so this is our n is equal to 1. So inside here we're going to have the nucleus. So imagine this is our nucleus. So with hydrogen, if we take hydrogen, hydrogen has one energy level, so this is n is equal to 1. So this is the first energy level that's closest to the nucleus. And within this energy level, it can store one electron. It has one electron, and that hangs out here. So if we can draw something like that. So that would be the first energy level. If we have a look at helium, so imagine we have, so this is our n is equal to 1. N is equal to 1. This is our energy level. So that's the nucleus. And helium has 2 electrons, so they will hang out here. So the capacity then for, that's the n is equal to 1, the first energy level, that's it at full capacity. It can only store 2 electrons. So then if we move down here, and let's say if we look at, maybe if we look at carbon here. So carbon, let's draw carbon. So carbon has 2 energy levels. So imagine these are the 2 energy levels. So we have the nucleus, so this is carbon. So the first energy level, so n is equal to 1, it can store 2 of the electrons. So if we have a look here, so carbon has 6 protons, therefore it has 6 electrons. So 2 of those electrons hang out in the first energy level, which is n is equal to 2, and then the remainder hang out in the second energy, which is n is equal to 4. Now, so the second, so you have 1, 2, 3, and 4. And these x's then, they just represent the electrons. So as we see here, this n is equal to 2. It has a capacity to hold 8 electrons. In the case of carbon, there's only 4 electrons, so it holds those 4. And then if we look down here at, if we have a look at chlorine then, for example, so chlorine actually has 3 energy levels. We'll just do these. So 1, 2, and then the third one. Oh, that. The third one then. This is chlorine. I'll just abbreviate, I'll use the chemical symbol, so chlorine. So chlorine's, the nucleus is in here. So chlorine then, if we look here, so chlorine has 17 protons, okay, so it has 17 electrons. 2 of them are in the first energy level, n is equal to 2. 8 of them are in the second energy level, 1, 2, 3, 4, 5, 6, 7, 8. So the first and the second energy levels are completely full, and then the remainder then, so we have 7 electrons left, and they hang out in the last energy level, or sorry, the third energy level. 1, 2, 3, 4, 5, 6, 7. So you have 7 electrons, so 7 electrons there. So that's the arrangement or the electronic configuration of chlorine. And it has a capacity for 8 electrons in its outer shell. Now, what's really important as well is that if we think about chemical reactions, so imagine we have atom A and then atom B. They have to actually come into contact with each other in order for a chemical reaction to happen. So what actually comes into contact with each other are these outer energy levels. And the electrons that are in these outer energy levels, they come into contact with each other first. So the outer energy levels are very, very important in relation to chemical reactions. So imagine this whole chlorine atom is moving in this direction. The outer whenever it comes into contact, it's going to come into contact with these outer electrons first. So what's important then is that also another kind of thing to know, and in relation to these outer energy levels and the electronic configuration of atoms and the periodic table. So if we have a look here, so we're having a look at the periodic table. So what we have here, if we look at these, so we have lithium, sodium and potassium, and we have the electronic configurations underneath here. So we can see here with lithium, it has 2 electrons in the first energy level. That's what this stands for. And then there's 1 electron in the outer energy level. Okay. If we take potassium then here, so potassium has 8 in the second, 8 in the third, and then 1 in the second. Now what you'll notice is, so these are all group 1 elements. So they come from this first group here on the periodic table. So we have hydrogen here, lithium here. So we have hydrogen, lithium, and potassium, which is here. So these are the 3 of them, and this is where they're represented on the periodic table. Now what you'll notice is that their outer energy level, or their outer region, or their outside shell, if you like, it has the same number of electrons. It has 1 electron in each. Now generally what happens is, so all of the group 1 elements, so remember this, so all of these, when you go down this group here, these are all group 1 elements. So remember, the vertical rows are the groups. So for example, lithium, sodium and potassium, as you move down this group, these are all group 1 elements. And what they have in common is that they all have 1 electron in their outer shell. They all have different numbers of protons and electrons, but when you come to the very outermost shell, all of the group 1 elements have 1 electron. If we take the group 2 elements, so like magnesium and these guys here, so within the group 2, so all of these guys here, they're going to have 2 electrons in their outer shell. If we have a look then, and that's the same then with all of these. So if we think about then, if we go right the way over to, so group 7, for example, group 7 will have 7 electrons in their outer shell. So if we have a look here, so we have fluorine and chlorine. So if we have a look here on the periodic table, here's fluorine and here's chlorine. They're all group 7 elements. And as you can see, if you look at the arrangement, they both have 7 electrons in their outer shell. So we can see them. So these are the 7. So these 7 electrons here in the outermost shell. So that's an important pattern. So generally what you have is, you have whatever group the atom belongs to, that also indicates the number of electrons that they have in their outermost energy level. And that outermost energy level is the one that's furthest away from the nucleus. So that is energy levels, and hopefully that makes sense, but just as a general introduction to energy levels, and looking at all of these energy levels in an atom. So as I was saying, an energy level is a region of definite energy within the atom that electrons can occupy, and they occupy them as per the capacity of each of the energy levels. So hopefully that makes sense, and thank you for listening.